Thank you, thank you, thank you. Thank you. Thank you. Josh, face this way. Alright, so let's look at these steps. And I think a lot of us started to see or understand that these steps are pretty valid, right? So the first step he took was he applied that commutative property. And we need to be intentional about this. Please be aware, I see a lot of students try to do this. If you are one of these students, please understand I'm not coming after you. I'm trying to help you learn not to do this. I see students do this all the time. Because what's negative 3x plus 3x? What is negative 3x plus 3x?
0.
0. When you add and subtract, you're trying to create a 0. When you multiply and divide, you're trying to create a 1. But that's creating a 0. However, what do the properties of equality tell me to do? Add it to just one side?
Both sides.
Both sides. Is that on the right-hand side or the left-hand side of that equation?
Yes.
He tried.
No.
No.
But it's on the left-hand side of the equation.
No.
Notice I've added 3x on the same side of the equation. That does not work. That is not going to maintain equivalency. You could add 3x to that side.
Yes.
Okay? You could. I'm not saying to do that, but I want you to be aware and to look at that. If you add 3x on one side of the equation, to make it stay equivalent, you have to add 3x to the other side of the equation. Overall,
2x.
in colloquial terms or in what people usually say,
What you gonna use in your class if you're on a test?
okay. The properties of equality are defined this way. So if A is equal to B, then if I add C, then I have to add C over here. Well, let's say it this way. If A is equal to B, this is why I don't like to do it super mathy. Then A plus C is equal to B plus C. A minus C is equal to B minus C. A times C is equal to B times C, and A divided by C equals B divided by C. What is that really saying though? That's a whole lot of letters, isn't it? That's why I don't like to do it super mathy. But that's what you asked for. Huh? Well, it's more, whatever I do to one side of the equation, whatever I do to one side of the equation,
You got to do
I gotta do the other side of the equation. That's what you've heard in the past. Okay. But that's what I was saying, like that's what you usually hear people say. It's not the most mathematically accurate. The most mathematically accurate is to say the addition property of equality, the subtraction property of equality, right? But that's the idea that whatever you do to one side, you have to do to the other. Okay?
Like also input versus output.
Well, you're thinking about functions. We're not talking about functions yet.
We're
Talk about it now.
We're gonna go over it again.
No, I guess it's geometry. We don't do functions here. Sorry.
Alright.
You'll deal with functions in Algebra 1 and Algebra 2. Alright, so it says that he applied the commutative property, he combined like terms, because what is 4x minus 3x?
1x.
1x. So x plus 6 equals x plus 1. And then it says he subtracted x from each side. Is that valid? Yes. Does 6 equal 1?
No.
No.
No. That statement is false. Will it ever be true?
Never.
Never. Wait, so this statement will never be true. Are there any solutions?
No.
No. That's why we would say this is always false. So then what you would respond with is no solution. He did every step correct.
Except for like 6 equals 1. Getting it that right.
That's not wrong. This equation doesn't have a solution. He did nothing wrong. He solved that equation perfectly. But the answer is that there is no solution to this equation. And again, this is where the properties of equality and equivalent equations are important. Would you have ever known that there was no solution looking at this first equation?
No.
No, I would kept guessing on that test.
Right, and that's what we need to recognize. If you use the guess and check method, that will not work out for an equation like this, because will you ever find a solution? No. That's why we like to apply commutative properties, distributive property, properties of equality, because now I get down to this really simple equation, and it's just like, well, nothing would make that equation true. So there's no solution in that case. We good with that idea? What did you all think about number 2?
The same thing.
Same thing, he made no mistakes?
I think he
So
made
there's
a,
just no solution?
I think he made a mistake.
You think he made a mistake?
Yeah.
Why do you think that?
You know the bottom part, right? Where he
Huh?
he got divide the x, right?
He divided the x?
Yeah, but he did it wrong. in my
Say-
opinion. He divided the s wrong, in my opinion.
Okay, so let's get to that point. So he applied the distributive property. What was that? Dude, pick up a pencil, take some notes. Okay, so he distributed. Will the distributive property create an equivalent equation? Will the distributive property create an equivalent equation?
Yeah.
So is that good?
Yeah.
Okay. So then he subtracted 10 from both sides. So minus 10, minus 10. 10 minus 10? 0.
Minus 1.
Okay, so 2x minus 1 is equal to 3x
Plus 1.
minus 1. 9 minus 10 is minus 1. Okay? Is that equivalent
Yes.
to what he started with? Yes? Okay. Then he added 1 to each side. Is that equivalent to what he started with?
Yeah.
Yeah? Okay. And then he did do a division property of equality to get 2 equals 3.
So then what do you divide?
So let's look at this. Can anyone think of any numbers that might have made this equation true?
2.
So if I substitute 1 in, I get 2 times 1 equals 3 times 1. Is that true?
No.
No. So 1's not a solution.
Yeah, I know.
-1.
Times 3. No,
So-
just kidding.
2 times -1 equals 3 times -1? Does -2 equal -3?
You have to
Josh,
find
put that
their
on.
common factor. I mean, just kidding. No, I don't like it. Oh,
That's great.
I don't like that.
Is 0 a solution?
Yeah.
yeah.
So is he correct saying that there's no solution here?
No.
No.
Oh,
Okay.
oh.
This is a note that you need to make to yourself. Because notice, he either used the distributive property or he used the property of equality the whole time, correct?
Yeah.
Okay? An invalid step is dividing, or let's say is using the division property of equality with a variable. Okay? The one thing that you cannot do with properties of equality is we cannot use the division property of equality with a variable. That is the one thing you cannot do with a property of equality. That is an invalid step. Notice when you divide by an x, you get no solution, but was there a solution?
Yes.
Yes. When you divide by x or divide by your variable, you will lose a solution to that equation. Do we see that and does that make sense?
Yes.
We're comfortable with that idea? Yes, Mr. Kenny, we're great. Awesome, great to hear, guys, thanks.
Welcome.
Real talk, like, does anyone need me to explain anything more with that, or do we understand that, and we made that note to ourselves here?
Yeah.
Yes.
Speak now or forever hold your peace.
I might have a question about.
Nope, as in you're not good, or nope, you don't have a question?
Oh.
I don't agree with
You ain't good?
Mm-mm.
About what?
Which step were you missing?
It wasn't that he was missing a step. This right here, you see how he divided by x at the very end?
He wasn't supposed to do
That is what I'm saying. An invalid step is using the division property of equality with a variable. When you divide by x,
Yeah, I see that. That was real dumb. That was,
you good though? But like that's the thing that I had to clarify, and if it was unclear, I need to tell you that. But notice we lost that solution of 0. That was the issue. Because 2 times 0 is equal to 3 times 0.
where's 0 come from?
Well, what are we trying to do when we solve an equation? Hold on.
0 is the solution to x.
Okay, so when we solve an equation, we're trying to find a solution. What is a solution?
The variable.
Say the thing that makes it equal.
So the value that makes the mathematical statement true. So I had to think about it. But I had to try to find a value for x that made this equation true. So Ireland, all I did was, I asked, will anything make this equation true? And the answer is a 0 makes that equation true. There's no special thing to do there. Thank you. Actually, I guess there is one thing you could do here. What's 2x minus 2x? 0. But I'd have to subtract 2x over here. And what's 3x minus 2x? 1x. So can I add and subtract with the variable? Yes. Can I divide by the variable and get a correct solution? No. Does that make sense, Marilyn? So notice 0 is the solution.
Okay, so when you're doing distributed property,
I mean, you can distribute. All I'm saying is you cannot divide with the variable. I cannot divide by the x. That's the only thing that's invalid. You get with that idea? Okay. So again, I need y'all to hear me very clearly on that. You can use the addition, the subtraction, multiplication properties of equality with the variable. You can do every property of equality with numbers. You just cannot divide by the variable. You will lose a solution. Okay? So if you need to continue making those notes, go ahead and do that while I pass out lesson 8.
Wait, do we have one more?
I will hand out.
what is this?
Yep.
I know how to do it, it's like.
That's the summary for lesson 7 and lesson 6. If you look on there, it literally says lesson 7 summary. So again, please notice I gave out a lesson 6 and a lesson 7 summary so that you can use that to help you study.
Wait, do you even have a grade in this class yet?
We get to see it.
And whenever they get whatchamacallit fixed, Power School.
I didn't do it this summer.
It fits in right there. You don't.
No.
Wow. How you know that? I would have been the other way. Huh?
Did I already give you all last night? Okay. I need us to start paying attention so we can look at lesson 8. You don't want to erase that.
You check me.
Terrence, I thought your head was hurting. Stop talking to my students and stop distracting. Do I not need to erase this?
You can erase the top part, but not the bottom.
Okay. Okay. Here is what we want to pay attention to in lesson 8 that I just passed out. One of the things I want you to understand is I've harped very heavy on the ideas of the properties of equality. Because what do the properties of equality create?
Equality.
Equivalent, not expressions, equations, right? Those properties of equality create equivalent equations, right? Which help us solve equations. But the focus really needs to be on equations with more than one variable. And that's what we're about to start looking at. Alright? Which kind of deals with functions, but not quite. And so here are the objectives that we want to look at. Given an equation, I can solve for a particular variable when the equation would be more useful in that form. And with that language, particular variable, how many variables do we think we're talking about? More than one. That's all I need you to understand at this point. We're going to start looking at equations with more than one variable, and we need to know when to use which form of that equation, because we've already seen it. Can you have more than one form that's telling the same story? Yeah, that's literally what equivalent equations are. So we need to figure out which one is the best and easiest to use. Yes, Terrence?
We're gonna do problems with more than two variables.
You can.
I'm talking about is we gonna do this.
We'll find out.
Wait, so you changing more than
I'm not
It doesn't-
Is there a variable going to have a solution to it?
Well, what is a, so here's what I want you to look, like legitimately, you're freaking out, some of y'all are freaking out. V equals length times width times height. How many variables are there?
4.
There's 4. Volume, length, width, height. But let's say I already know the volume, what I really want is the height.
Base times height.
Well, if I want to know that height, I can divide by length and width. Okay? Because what's length divided by length? 1. Width divided by width. And then volume divided by length times width is equal to height. That equation looks different, doesn't it? Is it telling the same story? Yes? Cool. Then that might be more useful if I'm trying to figure out what the height is. Because literally, we're saying that the height is equal to this thing. That's all I'm saying. Was that terrible, Terrence? With 4 variables? You're a whole lie. Did you even pay attention when I went over it? You're a liar.
I didn't pay attention, huh?
You're telling me that was terrible. That whole one single step.
That man don't want to step, man.
I had this, and then I had this. How many steps is that?
2.
Yeah, can you do the line?
1,
And then
2.
W.
This is what I started with. And so I took one step. Like if I'm here, I take one step.
You don't
I
count.
took 2.
No,
But
you
you
don't
did one
count.
like you did an L.
That was
You
2
count when you
steps.
take a step. Right.
Where you watching it?
I'm one step ahead.
That's 2.
Oh, you
This would be 2 steps.
You don't count where you start off at.
Yeah.
You count
Thank
when
you.
move.
You do not count where you start off at. You count the step. Okay?
Alright.
Now you're just trying to argue. Alright? And so we need to know what it means to solve for a variable. Alright, so here's what we're looking at. Which I'm going to make it dark so you can see this more clearly. So the table below shows the relationship between the base length B and the area of some parallelograms. All the parallelograms have the same height. Base length is measured in inches and the area is measured in square inches. Complete the table. Math at its core is patterns. Find the pattern so that you can figure out what the area would be here and what the base would be here. I'm not telling you exactly what to do. Just think about it. Talk with each other to see if you can figure out a pattern to figure out the rest of these values. Does that make sense? You just gotta play around with it. Talk about it with your group. Talk. Oh. Your job is to find the patterns with the, because notice how you are given, pay attention. You are given 3 bases and areas, the area that goes with the base. What is the pattern so that we can use these bases to get us to the area and these areas to get these bases? Okay? So work with your groups. Huh? We haven't done this one. We've done stuff similar, but not this one. Alright, hold on. Let me turn off the camera. Let's get to work. Well, it sounds like a personal problem.